Hello, and welcome to this short video introducing what a box and whisker diagram is, often called a box plot. I'll be interchanging between those two names throughout this video just so that you're aware. I think the best way to explain what a box plot is to use a cumulative frequency graph to show where these key values come from. So here I've got a graph, very poorly drawn I have to say, where we've got a range of values, let's say the time taken to complete a task ranging from 2 to 20 minutes for 100 people. Okay, and to start off with, we're going to do what we do with most cumulative frequency graphs and just draw out some lines from the quartiles. So from 25, the lower quartile or the first quartile, we've got around about, let's call that 7.5. From our median or second quartile, we go down, let's call that about 8.6. And from our upper quartile going across from 75 and down, let's call that 10.5. We've got three key values there. So we can say 7.5 is our lower quartile, 8.6 is going to be our upper quartile. I'm just going to move that 7.5 because that's at 7 at the moment. 8.6 is going to be our upper quartile, our median, sorry, and 10.5 was our upper quartile. Now, there's a reason I've drawn these this way, okay? Because what I'm going to do now is just move these slightly down, okay, onto a identical sort of scale, but without the y-axis this time. Now, why is this important, and why do we care about the spread of data from our lower quartile to our upper quartile? Well, it's because this represents the middle 50% of our data. And that's quite handy because it means that even though we had some values up at 20 and values down at 2, these might just be extreme values, freak results, someone who fell asleep halfway through the task and then woke up and finished it in 20 minutes, or someone who accidentally did the task without realizing beforehand. So what we generally do when we plot box plots is we don't represent the maximum value that we've got or the minimum value we've got unless it falls within reason. So a good sort of margin for error is to take our interquartile range. So in this particular case it went from 7.5 to 10.5, which is a interquartile range of 3. We times it by 1.5, which in our case gives us 4.5. Now anything that is 4.5 above 15, so anything above 15, if I knew the exact value, something like that, I would mark with a cross to indicate that they're outliers. Similarly, over here, I would have a 4.5 gap, okay, below my lower quartile, and anything under that would be considered an outlier, an extreme value. Okay, so why might we use box plots? Why are they interesting? Well, they really come into effect when we start comparing data. Okay, so below here I've got a second spread of data. So here's the girls' data from before. So I'm assuming that this box plot represents some girls' data. And next to it, I've got a whole bunch of boys' data as well. Now, for the sake of argument, I'm going to say that there were the same amount of boys as there were girls, 100 of each, but the boys' box plot looks very different indeed. The interquartile range, so that spread of the middle 50%, is much greater in the boys' data, which means the girls were much more consistent. Okay, if you can say that the vast majority, well, not the vast majority, but half of the data was within a tighter spread, you can sort of summarize that that group were more consistent. So even though the overall range for the boys is actually less than that of the girls, and actually the boys don't have any outliers, largely because their interquartile range is so big. We would probably say that the girls are more consistent in their approach. You can also start talking and comparing things like medians. Okay, so the boys' median is greater than the girls' median, which again would suggest they take slightly longer on average. Again, even though the time it took for the boy that took the longest was less than the two girls that took the longest for the girls. Okay, so this is really about the spread of data, and it's a really nice visual way to compare two groups.